start a new chapter, that is surface chemistry. In this chapter, what all we will study? We will study about the surface phenomena, the mechanism of adsorption, the classification mainly into physical adsorption and chemisorption, and what are their properties, about colloids and about emulsions. These are the important things that we will study in this chapter.
Students, in this video, just I will give an introduction about the topic surface chemistry. It's a phenomenon that occurs at the surface or the interfaces. So it's called as surface chemistry that occurs at the surface or the interfaces. Due to complete miscibility, there is no interface between gases. We know that in solids, at the surface and the below layer, there is an interface. Also in liquids, we can see that when we pour oil into a liquid, we can see there is a gap in between. That is an interface. That is, the oil layer will be on the top and the water will be in the downside. There is an interface for liquids. But for gases, due to complete miscibility, we can see that there is no interface between the gases. The next point is, molecules at the interface behave differently than the bulk. The molecule inside the solid will behave differently compared to the molecules on the surface of a solid. That is the point. Next is, the nearer the molecule is to the surface, the greater the magnitude of force due to gravity. That is, for the molecules on the surface, there will be gravitational force. So this is a solid. These are the molecules. Okay, the molecules. These are the molecules. This is the interface. Interface, what we call the interface. And this is the inside. This we can call it as the bulk. Molecules in the bulk. Okay. For the molecules inside, we can see that there will be force of attraction equally. Intermolecular forces will be acting, but that will be equal along all the sides and they cancel each other. Okay. There is intermolecular forces. Acting inside, but for the molecule at the surface, we can see that there will be force on the upper side that cannot be counterbalanced by the forces on the downside. That is the force due to gravity. Okay, this is what I told. These forces will cancel each other because equal and opposite forces are acting. But for the molecules on the surface, the forces will be different. That is, the molecules behave differently. The molecules at the surface will behave differently than compared to the bulk. This is the summary of what I have already told you. Molecules behave differently in surface and in the bulk. In the surface, it experienced an unbalanced attractive force resulting in a net inward pull, and that produces the surface tension. What is surface tension? It is a force with which molecules attract each other. That is called the surface tension. Next, what happens here? In the bulk, balanced forces from, that is, it experiences a balanced force from all sides and directions, and the molecules will be in a state of equilibrium. The molecules on the surface will experience an inward pull, while the molecules on the bulk will be having a equilibrium state. They will attain an equilibrium because the force will be equal in all directions and sides. The next important term to discuss is adsorption. AD. It's not absorption, it is adsorption. What is adsorption? The accumulation of molecular species. Accumulation of molecular species at the surface rather than in the bulk is called as adsorption. The accumulation of molecular species at the surface rather than the bulk is called adsorption. Solids that are finely divided state, that is, finely divided state means powdered state. Solids in the finely divided state will act as good adsorbents. Example, you can see silica are good adsorbents, charcoal means charcoal mask we have seen. In industries and all, they will use charcoal mask because it adsorbs poisonous gases. charcoal, then clay, colloids, etc. are example of adsorbents. It is the accumulation of molecular species on the surface, not in the bulk. Rather than the bulk, it is the accumulation on the surface. Good adsorbents are silica, colloids, clay, charcoal, etc. Look students, the surface on which the adsorption happens is called adsorbent. On this surface, adsorption, the accumulation of molecular species happens. So the surface is called what? Adsorbent. And the molecular species which adsorbs is called adsorbate. This is called adsorbent and this is called, the molecular species is called as adsorbate. The next topic to discuss is what are the causes of adsorption. It is caused by London dispersive force. London dispersive forces. It is a type of van der Waals force. Okay, it's a type of that is weak van der Waals forces that exist between the molecules, and it is also similar to the gravitational force that exists between the planets. Planets are far, but a gravitational force exists between them. Like that, weak forces are called as London dispersive force, and that is the cause of what? It is the cause of adsorption phenomenon. Let us discuss the thermodynamics of the adsorption. What happens in the adsorption process? During the adsorption, what happens? During adsorption, there is a decrease or a reduce in the residual forces. There occurs a reduce in residual forces. Reduce, or we can say a decrease. There is a decrease in residual forces. Okay, that happens what? There occurs a reduction in surface energy. Surface energy reduces. Energy on the surface reduces. Surface energy reduces. And this appears as heat. And this appears as heat. During adsorption process, what happens is that on the surface there occurs a decrease in the residual forces that are acting, and hence the surface energy, there will be high surface energy on the surface of a solid. That surface energy also decreases, and this decrease in the surface energy will be released now, that appears as heat. During the process of adsorption, what happens is that the adsorption process is fast. The accumulation of species is called as adsorption, that we learned. It is fast at the beginning. As the molecules get adsorbed on the surface, it becomes slow and slow. And finally it will reach the equilibrium. First it is a very fast phenomenon, then it slows down, and at last it reaches an equilibrium. First on the surface there is no molecules, no. So fastly the adsorption happens. As soon as the surface is full, then it slows down and reaches the what? Equilibrium. So we know that the equation delta G is equal to delta H minus T delta S. This you studied in thermodynamics, or you will study in thermodynamics. This is a Gibbs free energy equation for determining the spontaneity of a reaction. Delta G is equal to delta H minus T delta S. What delta G gives free energy, and delta H is enthalpy, T is the temperature, and delta S is the entropy. During the process of adsorption, we know that as attraction happens, the enthalpy decreases or the energy decreases, that we all study. So delta H becomes negative. As the attraction happens, energy is released and delta H, enthalpy, becomes negative. Also, the disorder decreases, that is entropy also. Delta S is entropy also becomes negative at the beginning. So we can see that T delta S becomes positive and delta H becomes also negative. That means delta G, totally this d delta S becomes positive and delta H also becomes negative. So this is at the beginning. And at the last what happens is, we can see delta H becomes equal to T delta S. This is the state of equilibrium. That is delta H and T delta S becomes equals at the last. That is the state of equilibrium state. This is what happens in adsorption. At the first stage, delta H and delta S becomes negative, and last, during equilibrium attaining, the delta H and T delta S becomes equals and the equilibrium is attained. Let us study the difference between adsorption and absorption first. Look, this is a case of adsorption. That is, the molecular species are adsorbed only on the surface and it will not come to the bulk of the solid. But look here, the molecules will enter or it will get absorbed to the surface inside the bulk. Okay, this is the difference between adsorption and absorption that we all know. When this adsorption and absorption together happens, that is termed as what? Desorption. This, when adsorption and absorption simultaneously takes place, then it is called as desorption. For example, consider when a chalk is dipped into an ink. What happens? Firstly, it gets adsorbed on the surface only. When we break it, we can see inside the color is white itself. But as time goes longer, what happens? It will get absorbed into the inner layers of the chalk also. So, chalk dipped in ink is an example of desorption process, where both the adsorption and the absorption takes place. Difference between adsorption and absorption phenomena. Adsorption is rapid at first and then slows near the equilibrium. We already studied. But absorption occurs at a uniform rate throughout. And adsorption is a surface phenomenon, while the absorption is a bulk phenomenon that we already studied. Occurs throughout the body. It's a bulk phenomenon. Next, high concentration of the molecules at the surface happens in adsorption, while in absorption it is uniform throughout. The molecular species are uniform throughout the solid surface, not solid in the bulk of the solid bulk, we can say. Okay, these are the main differences between adsorption and absorptions. Next important term is desorption. What is desorption? The removal of the adsorbed substances from the surface on which it is adsorbed. Removal of the adsorbed substance from the surface on which it is adsorbed. Next is the two classifications of adsorption. One is physical adsorption called Physisorption, and the other is chemical adsorption known as Chemisorption. What is physical adsorption or Physisorption? When the molecules of the adsorbate are adsorbed on the surface by a means of what? Physical forces or the weak van der Waals forces, it is called as physical adsorption. And when the molecules of adsorbate are adsorbed on the surface by means of chemical forces, strong chemical forces, it is called as chemisorption. If it is weak van der Waals forces, it is physisorption, and if it is chemical bonds, it is chemisorption. These are the two important classifications of adsorption. Let us discuss the difference between physical adsorption and chemisorption or the chemical adsorption. Usually weak forces are therefore physical adsorption, that is weak van der Waals forces, but for chemisorption it is strong chemical forces that act. There is only low heat of adsorption, 20 to 40 kilojoule per mole heat of adsorption for physical adsorption or physisorption. And there is high heat of adsorption, 200 to 400 kilojoule per mole for chemical adsorption. Why? Because strong forces are made. So, high heat of adsorption will be there. But for physical adsorption only low heat, because weak van der Waals forces are acting for physical adsorption. Physical adsorption occurs at low temperature. That is, the adsorption decreases with the increase in temperature. When temperature increases, the chances for physical adsorption is low. But for chemical adsorption, that is, it occurs at high temperature. And the physical adsorption is a reversible process, while chemical adsorption is an irreversible process. The next difference is physical adsorption is less specific in nature, while chemical adsorption is highly specific in nature. They form physical adsorption forms multi-molecular layers because weak forces are acting in between them. They form multi-molecular layers. Comparatively, the chemical adsorption only monolayer is required because the forces are very strong. Strong chemical forces act for what? Chemical adsorption. Next point is the extent of adsorption. The extent of adsorption increases with pressure for physical adsorption and it decreases with pressure for chemisorption. These are the differences between both adsorption, physical adsorption and chemical adsorption. Okay, students, today we discussed about the introduction of surface chemistry. That is, first about the phenomenon, it is a surface phenomenon. Next about adsorption we studied, differences between adsorption and absorption, and the classification of adsorption we studied, what are they? The chemisorption and the physisorption, their differences also we studied. That's all for today. Hope you understood what I have taught. If you have any doubt, you can comment below. Thank you and have a nice day.